I want to thank you, the organizers and sponsors, to make a space for this community where we can share our work and keep growing. I know it's a lot of work. I want to say thank you for bringing some like Barcelona weather to Boston for this week, although now it's raining, so like too much. You can access only a little bit to Boston weather. And I'm here to share our experience on this particular time where, as a bioinformatics core, we need to adapt to new technologies like NF-core, Nextflow, and Sequera. And I don't know if it's going to be useful for all of you, but as well, I hope that you can learn 5 facts that I put through the presentation, if this maybe is not something that is very relatable to you. But I think that it's going to tie it well with Geraldine's talk, actually, and Evan's talks, not in purpose, but it happened that way. So I want to present who we are for the ones that you don't know us yet, and how we are moving through Bcbio, who is the current technology to analyze sequencing data in the core, and moving to NF-core and what that means and how we are doing that and why it's something that you cannot just say, oh yeah, tomorrow we are start using NF-core, although we wish. But as well, what is next? We have been always very active in open source community, and we are going to continue doing that, but we want to do it in a way that is the most productive for everybody. So I want to introduce what is next. So this is us. Currently, there is a team of 13 people, plus the faculty advisory member. Shanna Hoshu, who is there, is the director of the core. She has been doing this for 10 years. And Mita Mistry is leading the teaching team in the core. And I rejoined the company, that is a story for another time, the core as director of bioinformatics platform. We are a group very diverse. That is brings me happiness every day that I start working, coming from very different backgrounds, very different technical experience, very different levels. So it's a place where you learn something every day. So I'm very happy to be there again. And as a vision, of course, like probably everybody here feels the same, we want to bring excellence doing bioinformatics data analysis. And we want to drive the discovery and innovation in our community. And how we are doing that is through the discovery of the cutting-edge bioinformatics solutions like NF-core and Sequera and Nextflow, and collaborative research and comprehensive training. And how we think is the best way to approach this is to have these 3 different branches in our group. The consulting, that is the main one in the sense that is bringing all this knowledge, because we work with a lot of groups in our community, Harvard, hospitals, even some industry. We work as a fee-for-service. Of course, platform is important, right? Because we're a big group, we do a lot of analysis. We really need to make sure what do we do, like pipelines, templates, how to do the downstream analysis, and how to communicate through visualization. And the teaching that at the end is very core to our heart, because it's where we are going to impact not only the people we work with, but we are transferring the knowledge to everybody else. At the end, this is what we aim for as well in the bioinformatics core. So just to give an idea of the amount of work we do, this is data that we have been accumulated for the past year. So from 2016 to today, that is why it's a little bit lower yet, but we are going to get there, is the amount of projects we have done, so around 250 projects a year. Across 10 different technologies. In the top, you can see that RNA-seq still is like very important. The trend there is that these bigger studies, a lot of more samples, more complexity in the experimental design. And then, for instance, the black part is the single cell and multi-omic single cells that keep growing. So this is what has been happening the most. And I think that Evans touched a little bit on this, is that the projects, they have 2 steps, right? They have the data processing, and it's where all the pipelines are involved there, where you need to choose what is the open source that you're going to work with, all the infrastructure behind that. There is a lot of options. And then there is the what is next. Like next is to do the data analysis, to understand the project, to make those decisions. At the end of the day, we are all here because we want to bring these new targets to the space, the therapeutic space, new platform, new therapeutic modalities, because we want to just make everything better, right? So we need all these to make this to happen faster. And I want to share a little bit how this happened, right? Like in time is very important. So Bcbio was born in 2011. First fact, the launch of the Space Shuttle Discovery happened that year, so good beginnings. And it was born because at that time, there was not clear platform for workflow manager for next generation sequencing data, and we were a core with a lot of projects happening every year, and we needed this reproducibility and scalability, and the most important, we needed to put the knowledge we have on how to do the best for each data type in a place, and that was Bcbio for us. So I don't know how many of you were actually analyzing next generation sequencing data in 2011. Can you raise your hand if you were analyzing sequencing data? Okay, good for the ones that they don't, and they didn't. I don't want to go ever back at that time. You learn a lot about life, but I would say, imagine that you need to go to a trip, but you leave, you don't have a smartphone, or you leave it behind, and you just need to get to a place you have never been, stay there for a week, and come back. So good luck to all of you. 2 years later, Bcbio got pretty well adopted by some industry. We have some good partnership at the time and academic labs. And at the same time, we found calcium deposits in Mars. Pretty cool. Getting there, we wanted to find water, but we just found calcium. But it was like we had very good developers, and everything kind of was like helping a lot to the core to get all this done reproducible. 1 year later, according to GitHub, I think that I was there, but I don't remember, is when Nextflow was born. By the way, that year it was when it was the first recorded meteor hitting the Earth. So a good year to start something, I guess. And Nextflow was born to be a workflow manager, right? Like to really be all flexible for any kind of analysis, to make it scalable, reproducible, and portable. And clearly, it got that. And 4 years later, and it's good that Geraldine and I have the same date. that would have been funny. I checked with fields, and then I checked GitHub. So NF Core was born as like a layer on top of Nextflow to make easy for everybody to build pipelines on top of Nextflow. And so first paper, or one of the first papers talking about mRNA vaccines for a virus, and 2 years later we all got one in our arms, or many. So you never know when a technology is going to boom. And clearly Nextflow and NF Core is doing that together with Sequera, so this is what we are now. And we have to adapt. It has been like a lot of years, and after going through this path, it's clear that we want to belong to the bigger community. And Bcbio, in a nutshell, is very focused in genomics, epigenomics, and transcriptomic analysis. Many of these applications are built in NF Core. It has 79 developers. It's an open source community. It's not only internal. It's still being used in many places, published, cited by more like 1,800 articles, and still being used. Say that I think that it's time to merge Bcbio knowledge into NF Core, and this is why we decided to go to that. And advantages we have seen it today, so I'm not going to go through that. Opportunities, contributing to a bigger community, as the core. It will facilitate Harvard community to use NF Core in their infrastructure. And even for us, as the people working in the core, is good for our career development. Like this screenshot of the, of the job descriptions were very clear. Challenges, because we all know that nothing is easy. There is a learning curve. There is some infrastructure that we need to adapt and make sure that we work in the right way. And we need to have a backward compatibility with Bcbio, because we have long-term relationship with everybody that we work with, and we cannot just switch the plug and then find that maybe there are like things that we need to explain. So we need to do the job of comparing results and comparing what is done in the different pipelines. So current state, I will use the next slide. We decided to divide this in 3 steps. The first one is thanks to AWS on one hand, but Sequera on the other. So Sequera has this free license for academia, and I really, please keep doing it for a while. It's helping a lot. In one day, I have everything running. I used it before, so it's not like it was new to me, but in one day it was running, so like I'm not even exaggerating here. So we started with RNA-seq, ChIP-seq, ATAC-seq, cut and run kind of pipelines. It's looking good. We found some gaps that we will contribute back to the different pipelines, but we want to really open that to the rest of the core. Right now it's like a few people testing it. So that is the first step, as adapting to the technology. And then we need to be compatible with the Harvard infrastructure, right? We are a big organization. We need to talk to them. We need to like find this middle point. And they are very, very helpful, but it's a big institution with a big HPC. So we are working, it's moving, because we want to make it available for everybody who cannot maybe have Sequera or an AWS account right now. And the final step will be to really be part of increasing the community inside Harvard. So we have the teaching team, and the idea is to contribute to the documentation and workshop material and create a space that is ready to use for them inside the Harvard community. So what is next, right? Like all this is good, we are moving, we are going to do it. But there is something that we thought a lot, and is what is our role in the open source community. So we created, not very like creative, I guess, like we decided to name Bcbio R, who you wouldn't guess is an R package. But it works, right? Bcbio R, that kind of works. We want to focus in the second step of the analysis, not more in the pipeline. The pipeline will be contribution to the NF Core. But we want to put all the knowledge that we have for this, like more than, I don't know, 250 projects a year into a structured template platform where it's compatible with NF Core output, and maybe you go and open Data Studio and get these templates, and it's much easier and compatible to do your analysis. It's not meant to be like click and point and run. It's really because every project is different. This is what we know. But it's meant to have all these different kind of analyses and guidelines that we can share internally in the core, and hopefully in the future with everybody, and hopefully people can contribute back. So Bcbio R kind of is the next step that we are looking for, very focused in complex RNA-seq and multi-omics single-cell RNA-seq. And then for NF Core, we need to fill some gaps between Bcbio and NF Core with the small RNA-seq, ChIP-seq, CLIP-seq, and ATAC-seq. And we are like playing a lot with spatial single-cell segmentation as well. So if anybody's interested in this vision, please reach out to us. We are going to work with the other cores in Boston to make this happen, and we are very excited to start this. And I'm going to end just for one more minute saying thank you to all the different organizations helping make this possible. The funding that we are getting right now, and I want to finish with this. So this is my last fact. So Liz Meitner was a physicist. She was partially contributed to the nuclear fission. She didn't get the Nobel Prize. Surprise. She was nominated though more than 20 times in the chemistry and physics Nobel Prize. That is a number, but she didn't get it. So I can like feel like I understand why she said this. But I think that everybody who is here in bioinformatics probably, it's never easy. It's like every day, it's every week. It's like, why I'm doing this? Like I don't know. I should go and like do other thing in my life. I don't know. But always there is this point where you see really what is happening after all the hard work. And I have been working in industry for 5 years. I have been actually working with like CEOs and business officer kind of level people. And this is impacting that process. And at the end of the day, even if it's long term, and even you won't probably know it, it's going to affect people's life. So keep it up. Good job. Thank you. And happy to answer any questions.
Thanks, Lorena. We have a question. Do you expect to teach your users to write pipelines or just use them, be able to troubleshoot, so the community you support as a core facility?
Internally or? Both. Okay, fine. I mean, we are going to keep contributing, so we are going to be developing. It's a balance that we need to just maintain in terms of, because we are not paid for developing pipelines, but we always find this margin. So the idea is that. In terms of externally, I mean, I think that it's both, right? Like we are going to make people use the pipeline and make people to be contributing to the pipeline. Like, I don't think that you need to choose, but internally, for sure, we have some people, including me, that will be developing.
Thank you very much. A round of applause, please.